Did China invent the bullet train? No. Did China invent the suspension bridge? No. Did China invent the solar panel? No. Did China invent the skyscraper? No. Did China invent 5G? No. So what exactly did China do with all of them? In field after field, technology after technology, China took ideas it did not create, systems it did not design, structures it did not conceive, and built them at a scale that made the original inventors look like they were still in rehearsal. This is the story of mastery. Japan invented the bullet train. October 1st, 1964. The Shinkansen launched the same week the Tokyo Olympics opened, and the world had never seen anything like it. A train moving at 210 kilometers per hour, smooth and silent, and on time to the second. The Japanese spent decades perfecting it. By the time China started paying attention, Japan had about 2,700 kilometers of track and a global reputation as the gold standard of rail engineering. China's first high-speed rail line opened in 2008, 44 years after Japan's. By most accounts, China was late to the game. Today, China operates 45,000 kilometers of high-speed rail. That is more than double the combined total of every other country on Earth. The Chinese did not just build more track, they built faster trains at lower cost across terrain that engineers in Europe called impossible, through mountains, across rivers, over permafrost. Japan kept the original idea. China kept the network that changed how 1 billion people move. And if high-speed rail felt like a one-off, wait until you see what they did to bridges. The suspension bridge is an American story. The Brooklyn Bridge, the Golden Gate, American engineers who turned a concept that had existed for centuries into something monumental. And the Golden Gate held the world record for longest span for nearly 30 years. For decades, the rankings were dominated by Japan, the United States, Denmark, engineering powerhouses with long traditions and institutional knowledge built over generations. China entered the rankings quietly, then it just kept building. Not 8 of 10, not 9 of 10. All 10 of the world's longest suspension bridges now sit inside China's borders. The longest, the Yangtze River Bridge, has a main span of 1,700 meters. The Golden Gate's 1,280 meters would not place in the top 20. Some call this infrastructure dominance. Some call it the logical outcome of building at scale. What nobody disputes is the result. But China did not stop at bridges you can drive across. They built bridges designed specifically to terrify you. The glass bridge was not a Chinese invention. Glass-bottomed walkways existed in tourist attractions across Europe and the United States for years, and nobody pushed the concept further than a novelty you might find at a theme park. China looked at that novelty and asked a different question, not can we build this, but how far can we actually take this? China has now built over 2,000 glass bridges and glass walkways. The designs include structures that flex visibly under your feet, panels etched to look like cracking glass, and bridges with no handrails, all of it engineered to maximize one specific sensation: controlled fear. The engineers understood something tourism boards had not yet figured out. Fear, when you survive it, becomes a story people tell for the rest of their lives. China monetized the sensation of almost falling, replicated it at national scale, and moved on to the next frontier, which was straight up. In 1990, China had essentially no skyscrapers. Not a handful, not a modest skyline, essentially 0 buildings over 40 stories anywhere in the country. The skyscraper was invented in Chicago. The United States built the Empire State Building, the World Trade Center, the Sears Tower. For decades, the tallest buildings in the world were American, then Malaysian, then Emirati. But then the sheer volume of what China was building made single height records beside the point. China now has more skyscrapers over 200 meters than the US and Europe combined. But the statistic that genuinely stops people is not about height. In 2015, a construction company in Hunan province built a 57-story tower, full building, fully functional, in 19 days. Prefabricated modules assembled on site with precision that would embarrass a Swiss watchmaker. The building passed safety inspections, it is earthquake resistant, and it is still standing. The same tower, using conventional Western methods, would take 2 to 3 years. China did not cut corners. China found a different process, and the process worked. What nobody wants to say out loud is that some of this infrastructure is now built better than the alternatives, faster and at lower cost. And that is not a political opinion. That is what the data says. But if you want to understand China's relationship with scale, you need to look at ports. The port of Rotterdam was, for most of the 20th century, the most important port on Earth, the gateway to Europe, the standard by which every other port was measured. Engineers visited Rotterdam to study it. Logistics textbooks were written about it. Then China decided it needed ports, and not just one or five, a network. Shanghai alone handles more container volume than Rotterdam and Los Angeles combined. Ningbo, Zhoushan, Shenzhen, Guangzhou, Qingdao, these are not just large ports. They are the arteries through which roughly 30% of global manufactured goods now flow. Rotterdam is still world-class, but it dropped from its century-long perch decades ago, and the gap has only grown since. When 7 of the world's 10 busiest ports belong to one country, what does that country actually control? Some say trade, some say something else entirely. The solar panel was invented in the United States. Bell Labs, 1954, an American patent, American engineers, American government funding. For decades, solar was expensive, fragile, and niche, the technology of satellites and eco-enthusiasts with very large budgets.
Germany became the first major economy to push solar at national scale, with feed-in tariffs and subsidies that put panels on every available rooftop. The EU invested, the US invested, and then China invested. Between 2010 and 2024, the cost of a solar panel dropped by over 90%. Not 20%, not 40%, 90%. The primary driver of that collapse was Chinese manufacturing scale. China also built the floating solar farm as a serious infrastructure category. The Huainan floating solar farm sits on a former coal mining subsidence lake and generates enough electricity for 94,000 homes. They built it on water they had poisoned with coal, which has its own kind of poetry. What strategists have been saying quietly about all of this is worth understanding. If China controls 80% of global solar panel manufacturing, it does not just control where the panels go, it controls the price, the supply chain, and in a very meaningful sense, the pace of the global energy transition itself. What if that is not a side effect? What if that was the goal? The electric vehicle was not a Chinese idea. Nikola Tesla did not work in Chengdu. Elon Musk did not found Tesla in Guangzhou. The intellectual heritage of the modern EV runs through American garages, Silicon Valley venture capital, and German automotive engineering departments. China looked at all of it and built BYD. In the first quarter of 2024, BYD briefly overtook Tesla as the world's largest seller of electric vehicles, a company that went from manufacturing rechargeable batteries to dominating global EV production in roughly a decade. China produced and sold more EVs in 2023 than the rest of the world combined. The West has responded with tariffs. The EU imposed duties of up to 38% on Chinese EVs. The United States imposed 100%. The official reason is safety and fair trade concerns. Some analysts accept that explanation. Others look at the price differential and suggest the tariffs have less to do with safety than with survival. What if the resistance is not about the car? What if it is about who controls the next 100 years of how people move? 5G was not a Chinese invention. The theoretical work was spread across American universities, Swedish laboratories, South Korean research institutes, Finnish telecommunications companies, Qualcomm, Nokia, Ericsson. The foundational patents run through Western and allied institutions. China built Huawei, and then China built the network, 3 million base stations. The United States, the country that wrote much of 5G's underlying theory, has roughly 100,000, not 300,000, 100,000. In China, 5G is not a premium urban feature. It covers cities you have never heard of, and farmers in remote provinces have better mobile connectivity than residents of American suburbs. The official Western concern about Huawei is espionage, that the infrastructure could be used to collect data for the Chinese state. That concern is real and documented. But flip the question. What if the more pressing issue is not surveillance at all? What if the country that deploys the most connectivity also shapes how the next global digital economy gets built? What if 5G is not just a phone signal, but an industrial operating system? The country that runs the network runs the factory. The tunnel boring machine was invented in America by James Robbins in 1952. For the next half-century, Western engineering firms dominated the industry. Herringknecht in Germany, the Robbins Company in the US, and the machines themselves were engineering showpieces, expensive and rare. China currently operates more tunnel boring machines simultaneously than the rest of the world combined. China is digging under cities, through mountains, beneath rivers. The subway systems of Chengdu, Wuhan, Xi'an, and Hangzhou, cities many Westerners cannot place on a map, are all currently under active expansion. The total underground rail network under construction in China right now exceeds the total existing underground rail in the United States. Execution at this scale was not inevitable. It required political will, capital allocation, and a decision China made before the engineering catch-up was even finished. China decided it would dig, and then it dug. The dam was not a new idea. The United States built Hoover Dam in 1936 and called it a marvel of the modern world, and it was 0.000 megawatts of generating capacity, a symbol of what industrial ambition could accomplish. The Three Gorges Dam produces 25 times the power output of Hoover Dam. It is the equivalent of burning 50 million tons of coal per year, captured as clean hydroelectric power. But the engineering detail that will genuinely stop you is not the dam, it is what they built beside it. The project includes a ship elevator that lifts vessels weighing up to 3,000 tons, a vertical distance of 113 meters, in roughly 40 minutes. A ship the size of a small cruise liner, picked up and carried upward by a machine. The elevator exists because the dam blocked river traffic. China did not reroute the ships. China built a lift for them, and they are still building. Rail, bridges, glass, skyscrapers, ports, solar, EVs, 5G, tunnels, dams. These are not military victories or economic statistics. These are physical things you can stand next to, walk across, ride inside, and be stunned by. The country that built all of them in roughly 30 years, the one you have been calling a developing economy, is not slowing down. Stay with this. The West stopped building nuclear power plants after 3 Mile Island in 1979 and Chernobyl in 1986. Fear, regulatory paralysis, public opposition, a generation of politicians who found it easier to pause than to rebuild public confidence. France remained a partial exception, but even France slowed. Germany shut its plants down entirely. The United States spent decades not building. China has more reactors under construction right now than any other single country on Earth, and it has approved plans for dozens more. But the engineering story inside Chinese nuclear is not just about volume. It is about a specific failure mode that stopped the West cold. Chernobyl and Fukushima shared the same weakness. When cooling systems lost power, the reactor kept generating heat, and without active cooling, pumps running, power flowing, the core melted down. China's Hualong 1 incorporates passive safety systems. If everything fails, power, pumps, human operators, the reactor cools itself using gravity and convection, with no electricity required and no operator action needed. Physics does the work. The West designed reactors that required active management to stay safe. China designed a reactor that stays safe when nothing works. Some say the West's abandonment of nuclear was rational caution. Some say it was the most expensive strategic mistake of the last 50 years. Step back from any individual category and look at the pattern. Japan invented the bullet train, and it runs on 2,700 kilometers of track. China took the same technology and built 45,000 kilometers of it. American engineers pioneered the suspension bridge. China built all 10 of the world's longest. Bell Labs invented the solar panel. China now makes 8 of every 10 sold on the planet. There is a stage of innovation that has no glamorous name. It is not discovery, and it is not breakthrough. And it does not make the history books the way the original idea does. It is the unglamorous, relentless, systematic work of taking what exists and scaling it until it becomes the new normal. China did not win the patent race. China won the execution race. And execution at true scale, at the scale of a civilization making a conscious decision to build, is its own form of genius. Unromantic, bureaucratic, engineering-minded, applied not to the question of what is possible, but to the question of what can be delivered, right now, for 1 billion people in the next 10 years. The West invented many of the tools. China used them. What did China build that surprised you most? Not what you think about it politically, not what it means for your country's economy or security posture. What surprised you? Because somewhere in that answer is where you thought the limit was. There is a word the history of technology uses for what happens when someone takes an existing tool and does something with it that the original inventor never imagined. The word is not copycat or theft or imitation. The Wright brothers invented powered flight, but the country that built the air transport network connecting the modern world was not the United States, and it was not in 1903. Gutenberg invented the printing press, but the explosion of literacy that followed happened across a continent that did not own the press. Inventing something is one thing, knowing what to build with it, knowing how to build it at the scale of a civilization, knowing how to iterate and fund and deploy and refine until the original inventors are sending their own engineers to study your version. That is something different. Mastery. If you made it this far, you want to understand how the world actually works, not just how it gets reported. Next video. What happens when a country that built all of this starts exporting the model? The Belt and Road Initiative is not an aid program, and the countries signing up are not doing it out of gratitude. Click it on screen.